Today we're going to do lesson 9.5, which is solving quadratic equations using the quadratic formula. Now, before we get into this new method, let's talk about the three methods that we have already learned. Okay, what was the very first method we learned back in 9.2? It was your flipped classroom. How did we solve quadratic equations in lesson 9.2? Graphing. All right, very good. In 9.3, we learned how to solve quadratic equations using what? Square roots. In 9.4, we learned how to solve quadratic equations by what? Completing the square. And today we're going to learn the quadratic formula. So after today, we will have 4 different ways to solve a quadratic equation. Now, some of those methods had stipulations on them. For example, if we were going to solve using square roots, and you just wrote a whole journal entry on this, what has to be the case in the original problem? If we're going to use square roots to solve, what's the only variable term that can be in the problem? X squared. Okay, it can't have an x squared and an x. All right, graphing did not have a stipulation on it. Okay, any problem can be graphed. Completing the square. Completing the square just has to have an x squared term, an x term, and a constant. But where does the constant have to start if we're going to complete the square? You remember?
In front of the x.
No, the constant is the number without a variable. So when we start a completing the square problem, where does the constant need to be?
On the other side.
On a side by itself. So away from the x squared and the x. All right? So that brings us to our essential question. How can you derive a formula that can be used to write the solutions of any quadratic equation in standard form? Now, let's talk about the solutions. Every time we've solved a quadratic equation, what have we been finding?
The solutions.
What are the solutions? No. Think back to the graphing method. That's when you were first introduced. The x-intercepts, all right? Where do these equations cross the x-axis? Those are the solutions to all of these problems. The place where the graphs cross the x-axis. So that can be found when a problem is in standard form. Well, what is standard form?
Ax squared plus bx plus c.
All right, standard form. We've been dealing with it for a while now. You've written it down in your notes today. Okay, so what are we going to do when the quadratic equation is in standard form? Well, today we're going to start with something called the discriminant. So if we want to know, without actually solving the problem, we want to know how many solutions the problem will have, we're going to use this tiny little formula called the discriminant. So I want you to highlight that formula. B squared minus 4ac. Now, if you remember standard form, ax squared plus bx plus c, then finding a, b, and c to plug into this formula is going to be real simple. A is the coefficient of x squared, b is the coefficient of x, and c, of course, is the constant. Now, when you're finding the solutions to the discriminant, you are finding the number of x-intercepts, the number of solutions, right? So look at this. If your discriminant is a positive number, you're going to have 2 solutions. If your discriminant is 0, you're going to have 1 solution. And if your discriminant is a negative number, you're going to have no solutions. Does that look familiar to anyone? Yes. Where did we see this same type of setup? In which lesson? 9.3. Except we had to isolate x squared. When x squared was equal to a positive number, there were 2 solutions. When x squared was equal to 0, there was 1 solution. And when x squared was equal to a negative number, there were no solutions, okay? So the discriminant is just a different way to get to the same conclusion. How many solutions is our answer going to have? So in example number 1, it says determine the number of real solutions to the equation. So we are going to use the discriminant. We can't isolate x squared because there's an x squared and an x term. So we're going to have to use the discriminant. Now, in order to do that, in order to identify A, B, and C, we've learned in the past that everything has to be where? On one side, set equal to 0. So looking at letter A, is that the case right now?
No.
What do we need to move?
-1.
Right, and how are we going to move it?
Add 1.
We're going to add 1 to both sides. Now, since there's no like terms on the left side, we're just really going to focus on bringing down the problem in standard form. So descending order, 6x squared plus 2x plus 1. And of course, over here, it cancels and gives us 0. Now, can we identify A, B, and C? Yes. A equals 6, B equals 2, and C equals 1. Again, the coefficient of x squared is A, the coefficient of x is B, and the constant is C. Now, let's write down the discriminant, because the more we write it down, the easier it is to memorize. So everyone together, the discriminant is b squared minus 4ac. Now, what are they asking us to do to 4a and c? Good. There's no sign between the 4 and the A and the C. So this is multiplication. So we plug things in parentheses. So let's start with B. What is our B value? 2. And we're going to go ahead and just plug everything in parentheses. So 2 squared minus 4 times A. What's A? 6 times C, which is 1. Now, according to the order of operations, what do we have to do first? Exponent. So what is our exponent? 2 squared. What is 2 squared? 4. Now, go ahead and bring the minus sign down so when you multiply, you can just focus on 4a and c. What is 4 times a times c? 24. So, what is 4 minus 24? Negative 20. And we're going to box that in because that is the solution to the discriminant. It's negative. Okay? The discriminant is a negative or has a negative value. So, how many solutions will this equation have if we solve it? 0. Okay? So no solution would be the second part of our answer that we write down and we box in. So we're going to box in the value of the discriminant because that tells us what we need to know. And since it's negative, there are no solutions. This graph would never touch the x-axis. All right, now let's look at letter B. Is this problem in the correct form to identify A, B, and C? No. Now, we attempt to never have a leading coefficient that is negative because there are so many problems that we work where our leading coefficient needs to be positive. So we don't want to make the leading coefficient negative if we don't have to. So what would we move so that everything is on one side?
7x.
The 7x and the 1. Okay? It's a little bit more work, but at least we will have a leading coefficient that is positive. So how do we move the 7x? Subtract it. And how do we move the negative 1? We add it, okay? And we're going to break a rule and we're just going to do everything at once, okay? Mainly because there's nothing alike on the left side. So we just got to get everything brought down in standard form. So 1/2 x squared minus 7x plus 1 equals, of course, these cancel and leave us with 0. Now can we identify A, B, and C? Yes, A equals 1/2, B equals -7, and C equals 1. All right, let's write down the formula. What is it, everybody together? B squared minus 4AC. So what is our B? -7. Be careful. Minus 4 times what's our A? 1/2. And what's our C? 1. All right. Oh, I forgot the squared. What do we do first? The squared, the exponent. The exponent. So -7 squared is
49.
Positive 49. We bring down the minus sign so we can just focus on 4 times 1/2 times 1. This table right here, tell me, what is 4 times 1/2 times 1? 2. So what is 49? This table again, somebody new at the table. What is 49 minus 2? 47. We box that in. Since the value of the discriminant is positive, Emma, how many solutions does this problem have? 2 solutions. So if we were to graph this, it would cross the x-axis twice. There are 2 solutions. That leads us into example number 2, which says find the number of x-intercepts of the graph of the function. How are we going to do that? What are we going to use to find out how many x-intercepts the graph would have? Do you think we're going to do anything different than we just did in example 1?
No.
Because the solution to quadratic equations, what are the solutions to quadratic equations? X-intercepts. So here's what I would do if I were you. I would highlight in example 1 where it says real solutions, and then I would highlight in example 2 where it says x-intercepts. That way, as I'm looking at both of those problems, I recognize that no matter what they're asking me for, solutions or x-intercepts, the method to get there is the same. It's the discriminant. All right, now look at letter A. We have learned that we can replace f of x or y with what value?
0.
So that's the first thing we got to do. 0 equals x squared plus 12x plus 36. Now are we able to identify A, B, and C?
Yes.
Yes, so A equals 1. Good. Understood coefficient of 1. B equals 12 and C equals 36. All right, what's the discriminant? B squared minus 4AC. All right, work with your table and finish this one. And then go ahead and work letter B as well. What did you guys plug in place of B? 12 squared minus 4 times, what did you plug in place of A?
1.
And in place of C?
36.
What was 12 squared? 144. Bring down the minus sign. What was 4 times 1 times 36? And 144 minus 144 was?
0.
So, how many x-intercepts, if the discriminant value is 0, how many x-intercepts are there? 1, and make sure you don't put one solution because they asked me for how many x-intercepts. So it's 1 x-intercept. This graph would cross the x-axis 1 time. All right, so be very careful. Don't tell me solution if the instructions ask for number of x-intercepts. All right, letter B. What did you replace y with?
0.
Good. And then was it ready for you to identify A, B, and C?
Yes.
So A equaled -1, B equaled +1, and C equaled -6. All right, the discriminant is B squared minus 4AC. What was B? 1 squared minus 4 times A, -1 times C. Okay. Everybody else, what is 1 squared?
1.
Okay. Bring down the minus sign and focus. What is 4, Noah, times -1 times -6?
-24.
Be careful. We brought down the minus sign, so we're literally focusing on what I underlined. 4 times -1 times -6.
24.
That's positive 24. So now we have 1 minus 24. All right, what is 1 minus 24?
-23.
-23. And if the discriminant has a value that is negative, how many x-intercepts are there? None. So 0 x-intercepts. If you want to put no x-intercepts, I'm okay with that as well. Okay? As long as you say x-intercepts and not solutions, because this problem asks for the number of x-intercepts. That leads us into the quadratic equation. All right? And what do you notice right off the bat? What looks familiar to you when you see the quadratic equation or formula? The discriminant is in there, and it's a really big part of the quadratic formula. So if you just mastered the discriminant in the last 4 questions, then the quadratic formula is going to be easy for you. All right, but look what I say. I say memorize it, and here's why. It's one of those formulas that's not going anywhere anytime soon. You are going to need it for a very long time to come. So committing it to memory is a really good idea. But notice this about the quadratic formula. We are very used to formulas being f of x equals or y equals. But remember, when we're solving quadratic equations, we're looking for what? X-intercepts. So the formula is x equals. It's negative b. There's already a negative in the formula. That will be important in a few minutes. Plus or minus. We've seen the plus or minus symbol before. The square root of b squared minus 4ac. So the discriminant's in there, but this time it's under a radical. And then that's divided by 2 times a. All right, so let's go to our flow chart and let's look at question number 1. And I want you to notice the directions. Round your solution to the nearest tenth. So this tells me either I'm going to have whole number answers or I'm going to have decimal answers. I won't have to do upside down division to simplify because I'm going to be allowed to give decimal. We look at the question, and in step number 1, the box, it says, is it set equal to 0? So is our equation set equal to 0? Yes, so we can follow that arrow over to the yes, and it takes us down to step number 2 where we're going to find the values. A, B, and C. A is the coefficient of the x squared term, B is the coefficient of the x term, and C is the constant term. So looking at our problem, what is the value of A?
X squared.
What's the value of A? The coefficient of x squared, which is 1. What is our B value? -6. And what is our C value? 5. Now we follow down to step 3 and we simply plug it in. Now right now they've given us the formula, but like I said, you're going to have it memorized for a quiz or a test, all right? The first set of parentheses is B. What is our B value? Make sure you plug in a -6. There's already a negative in the formula, so we have to plug the negative in with the 6. The second set of parentheses is B again, so that's -6. The next set of parentheses is A, which is 1, and the next set is C, which is 5, and that's all over 2 times A, which is 1, all right? Now follow over to step number 4. It says tidy up. Here are the 4 things we got to tidy up. Simplify any double negatives. So if you go back to the problem, do you see any double negatives?
Yes.
Right off the bat at the front of the problem, there's a double negative. So x equals +6 is what we're bringing over with us. Then it says calculate the discriminant. So take your calculator. Don't worry about the radical right now. We're going to leave the plus or minus and the square root in the problem. So in your calculator, just do the discriminant, which you got to be careful. That's a -6 squared. So make sure on your calculator you put -6 in parentheses and then you square it. If not, it won't give you the correct sign on your answer. So we've got -6 squared, and then it's -4 times A, which is 1, times C, which is 5. So what does that give me under the radical? What's the discriminant value? 16. And then it says to simplify the denominator. So what is 2 times 1? 2. And then it says rewrite the equation, which we kind of did that as we went. Now that takes me to step number 5 where it says simplify the root. So again, we're either looking for a perfect square or we're going to leave it as a radical because we're allowed to put our answer to the nearest tenth. So we're going to be able to do a decimal answer. But what's the square root of 16? 4. So x equals 6 plus or minus 4 divided by 2. And again, it tells us to rewrite the equation, and we did that. Now, follow over to step 6. I love this. It says, do the plus or minus. So calculate the 2 versions of the numerator. Remember last week when we got introduced to this sign? We have to remember that makes the 4 positive and negative. So we're going to have 2 different answers. So let's do 6 plus 4. So in step number 6 box, what is 6 plus 4? 10 divided by 2. We're going to leave it. And the other one, what's 6 minus 4? 2 divided by 2. And that leaves us with step 7, which is to simplify. So what is 10 divided by 2? 5. And what is 2 divided by 2? 1. So there are our 2 x-intercepts. Now look at letter B. Again, the first question is it set equal to 0? So what's our answer this time? No. So we have to follow the no box where it says rewrite your equation so it is equal to 0. So what are we going to have to move so that the problem will be set equal to 0? Okay, -1. And how are we going to move it to the other side? We're going to add it. It's already -1, so we're going to add it to both sides. So we rewrite it as 4x squared minus 4x plus 1 equals 0. Now we can go to step 2. And what is my A value? What's my B value? -4. And what's my C value? 1. So let's plug that in. The first set of parentheses is B, which is -4. The next set of parentheses is B, which is -4. The next set is A, which is +4. And the next set is C, which is 1. Of course, divided by 2 times what's A? 4. All right, let's tidy up. Do we have a double negative this time? Yes. So x equals +4 plus or minus. Let's figure out the discriminant. So remember, we got to put -4 in parentheses, square it, and then -4 times A, which is 4, times C, which is 1. And what does that give us under the radical? 0 divided by what's 2 times 4? 8. All right, now let's simplify the root. We have x equals 4 plus or minus, what is the square root of 0? 0 divided by 8. Now go to step 6. Is it necessary for us to calculate the two numerators this time? What's 4 plus 0?
4.
What's 4 minus 0?
4.
So either way, we're going to get the exact same numerator. So we're just going to write that problem down once. All right, so we're going to write x equals 4 divided by 8. So that makes our final answer, x equals 1/2. This graph would cross the x-axis one time. Now, what do you do if you get to a problem like example 4 and it says solve the equation using any method? And we talked about this at the beginning of the lesson. What were the two methods that really would work on every single problem? Graphing and what we just learned, the quadratic equation, right? Because we can always identify A, B, and C and plug it into a formula, all right? But there's a stipulation on using square roots, and there is a little bit of a hesitation on completing the square, all right? There's a couple things that you want to make sure are happening for you to complete the square. First of all, where does the constant have to be in order for us to complete the square? On a side all by itself, right? We also need the leading coefficient to be a what? 1. So personally for me, if I'm picking between completing the square and the quadratic, I'm probably going to pick the quadratic, all right? So look at letter A. Which methods would work on letter A? Just go through them in your mind. Would graphing work?
Yes.
Absolutely, but we don't have Desmos with us right now, okay? So it's probably not the most convenient, all right? Would using square roots work on letter A? Why not? There is an x term in letter A, and we can't use square roots if there's an x term, so we can eliminate that. Could we complete the square? We could move the constant over by itself to the other side of the equation, and the leading coefficient is 1, so if you like completing the square, you could complete the square on this one. All right, and then lastly, the quadratic equation. Could we use the quadratic equation? Yes. Now, I want us, just because it's a new method and I want to practice it a little bit more, let's do the quadratic equation without the flow chart. All right, so is it ready for us to identify A, B, and C? Yes, it's set equal to 0. So what does A equal?
1.
What does B equal?
11.
What does C equal?
-12.
-12. Now we're going to write down the formula because they didn't do it for us this time. So x equals negative b plus or minus the square root of b squared minus 4ac all over or divided by 2a. All right, let's plug it in. X equals negative, what's our b? 11. And notice I'm going to plug it in parentheses every time. Plus or minus, again, what's b? 11 squared minus 4 times a? 1 times c? -12. And pull that radical over it because you need it over the entire discriminant, and then divided by 2 times a. What's a? 1. Awesome. So x equals, do we have any double negatives? No, so we're just going to pull down a -11 plus or minus the square root of. Okay, grab those calculators and just calculate the discriminant. So 11 squared minus 4 times 1 times -12. And what does that give me under the radical? 169 divided by, what's 2 times 1? 2. Now we simplify the root. So -11 plus or minus. Is this a perfect square? What's the square root of 169? It's a perfect square, so it's 13 divided by 2. All right? Now we're going to calculate both numerators. So help me out here. It's -11, what? Plus 13. What's a -11 plus 13? 2 divided by 2. And then we got to do -11 minus 13, which is -24 divided by 2. All right, you guys keep working down. I'm going to have to work over here to the side. This makes my final answers x equals 1 and x equals -12. Now, if you were on your own and you chose completing the square, you would get the same exact answer. All right, so completing the square or the quadratic equation or graphing would get you the same answer every single time. All right, let's look at letter B. All right, again, go through your choices. Would graphing work on this problem? Yeah, but again, it's not super convenient, so we're not going to do graphing. Would square roots, using square roots. Why would using square roots work on this one? Okay, there's not an x term. So that's actually what we're going to do. However, before we do it, let's talk about completing the square. Could we complete the square on this one? Is it going to make a lot of sense? Because remember, we're supposed to be taking b, dividing it by 2, and then squaring it. Well, we don't have a b value, right? So it would be 0. It would just, basically it's going to come down to is we're going to be isolating x squared. So completing the square just doesn't make sense. Could we do the quadratic equation? Yes. Could we identify a, b, and c? Yes. What would our b be?
0.
And we could plug a 0 into the quadratic equation. So the quadratic equation does work. However, which is the quickest and the most convenient? If all we have is an x squared, then what would be the quickest? Square rooting. Okay, so what do we do first in letter B to get x squared by itself? We add 5. We add 5. So we have 9x squared equals, what's 4 plus 5? 9. How do we get x squared by itself? Divide both sides by 9. So x squared equals 1. Now, according to this, how many solutions should we end up with at the end? If x squared is equal to a positive number, we should have how many solutions? 2. All right. How do we then solve for x? Because this is x squared and we need to solve for x. We take the square root of both sides. Now, we put the radical in the problem. What else do we have to put in? The plus or the minus. So what is the square root of x squared? And it equals plus or minus. What's the square root of 1? 1. So that is a whole lot quicker than using the quadratic equation or the quadratic formula. We could, but this is definitely the quickest. And that is 9.5.